Here's problem 1732. An airplane traveling at half the speed of sound emits sound at a frequency of 5,000 hertz. At what frequency does a stationary listener hear the sound as the plane approaches and after it passes by? Assume the airplane is not flying very high. So this is pretty dangerous. So you have a jet airplane flying just off the ground, flying at a speed equal to, so the velocity of the source is 1/2 the velocity of sound. And you're an observer listening to this, hopefully not too intently because it's pretty dangerous. So if it's approaching, then we have that the observed frequency should equal the actual frequency, velocity of sound, plus or minus the velocity of the observer, over velocity of sound minus or plus the velocity of the source. In this case, the velocity of the observer is 0, and the velocity of the source is 1/2 the velocity of sound. So, as we put in our numbers, this is going to be 5,000 times the velocity of sound over the velocity of sound, and since it's moving toward you, we're going to use a top minus sign, 1/2 the velocity of sound. So this is going to be 5,000 times the velocity of sound over the velocity of sound times 1 over 1/2, which is just going to be 2. So the observed frequency in this case is going to be 2 times 5,000, or 10,000 hertz. Okay, if it's backing away, what do we have? The observed frequency in this case is equal to actual frequency, velocity of sound, plus or minus velocity of the observer, over velocity minus or plus velocity of the source. In this case, the observer is still stationary. Velocity of the source is still 1/2 the velocity of sound. And we have that this is equal to 5,000 times the velocity of sound over the velocity of sound. We're going to have plus because it's backing away, so we're going to use the bottom plus sign, 1/2 the velocity of sound. This is equal to 500 times the velocity of sound over the velocity of sound times 1 over 3/2. So this is going to be 2/3 times 5,000, or 3,333 hertz. So as it's approaching, it's twice the frequency, 10,000 hertz. As it's backing away, it is 3,333 hertz. Answer.